Okay, so we're going to do isolating variables, but using the combination formulas. So this symbolism, or these symbols here, are difficult. They're not what we're used to seeing when it comes to an isolating variables equation. We're used to some usually specific notation. What we have to realize is this is a notation that can be used for the function of a combination. So in other words, let's do our example in red here. I can say n choose r, and that gives me a formula of n factorial over n minus r factorial times r factorial, which is also equal to writing this. It's kind of like a double input for a function. There's an n and then there's an r. So in other words, this here, if I don't count this thing in the middle, is equal to this. So if this looks confusing, I can rewrite this as a combination formula and then put it into this. This is the style we need to use, except they just didn't write it that way. They used a different symbol. Okay, so I'm going to show you how that same question. So that's 4 times n times r. Well, in this case, it's n2. So we have n choose 2 is equal to. So think of them like separate brackets. Okay, and then in our other one, we have n minus 2 choose 3. Okay, so I'm going to rewrite the other one above. So we had n2 is equal to n minus 2, 3. Okay, so if you noticed, I changed this into a combination. Yeah, and I changed this into n minus 2, choose 3. Now we're going to have to kind of change it again. I didn't have to go through this many steps, but I want you to see the progression. But now we're going to write it like this fractional answer. So that 4 is still going to stay on the outside. And now what we have is our n factorial. Well, our n factorial is still n. So n factorial over n minus, well, 2 is our r value, factorial, times 2 factorial. Okay? And in this case here, we have n minus 2 factorial over our n value is going to be n minus 2 minus 3 factorial, and then the r value is 3 factorial. Okay, so again, I'll kind of highlight what we did.
Oh, and can you do some canceling?
Yes, we're going to have to do a lot of this stuff. So we have these values here. So that little bracket of 2 inputs essentially equates to this. Okay, they've just written in a different symbol. So now, without all the green and everything, we're going to actually try to work this out. So one thing we can do is try to work out what our factorials are. So for instance, n factorial, there's not much I can do there, but I can distribute this 4. Think of this like as being a fraction times a fraction. So it's 4 over 1 times that. I would do the top by the top, bottom by the bottom. The 1's not going to change anything, but we can kind of write the top here as 4 times n factorial over 2 factorial. 2 factorial is just 2, so I'm going to bring that to the front. And then n minus 2 factorial. Well, this is tough because we don't know what the n is, so we don't really want to go into like a distributing here. Because a factorial is essentially, we've got to talk about what a factorial is. If we said n factorial would be n times n minus 1 times n minus 2, all the way down to the value of whenever that value is equal to 1. But we don't really know what it is yet, so we can't really expand that value either. Okay, so on the top, we're still going to have to leave this n minus 2 factorial, because we really don't know what n is, over. So from here it gets kind of tough. I was originally thinking that we could, because we have equivalent fractions, we could kind of cross multiply, but it's not going to help. It's going to make things actually more complex. So what I can do is try to expand these concepts. So I'm just going to focus on the left side here. I always get these mixed up when I'm looking. Okay, left side, right side. Let's focus on our left side for a second. So I'll do it in blue here. Well, we know that's the number 4. n factorial, I'm going to expand. So n factorial becomes n times n minus 1 times n minus 2 times n minus 3 all the way down to the value of 1. We don't know exactly what that is, but it does go down to the value of 1. Let's make it all blue. Okay. I wish that was a solid line. What can you do? And then we have 2 here. Well, here we have n minus 2. So what that means is this actually starts at n minus 2. So it's times n minus 2 times n minus 3 times n minus 4 all the way down to 1 again. So if you notice, we have a similarity. From n minus 2 all the way down to 1 exists on the bottom. N minus 2 all the way down to 1. In other words, these are the same values. And because this is all multiplication, when you divide these values, they create a 1, or the idea is that they cancel out. So we can cancel all of this out, and now we're left with, and again, I can reduce this 4 over 2 also. So let's make that the value of 2. So it becomes 2. So that this 2 on the bottom is actually also gone 2. Turn this into the value of 2. So it becomes 2 n times n minus 1. Okay, so we kind of have 3 separate terms just on the left side. So we just simplified that left side to 2 times n minus 1. Okay, we can do something very similar on the right side. We'll do this in green, the right side. So we're doing the left side, or sorry, right side here. And we realized we wrote the question down just a little wrong, so we can fix it because it's not costing us too much yet. This should have been n plus 2, correct?
Yeah.
So if this is a plus, not a big deal. We just kind of go through here, plus 2. And then this will be a plus. So if this is a plus, this becomes n minus 1. Because positive 2 minus 3 is 1, so n minus 1. So now when we go to simplify this right side, okay, we get n minus 2 on top. We'll expand it. Oh, sorry, I said I was going to do it in green here. N minus 2 times n minus 1 times n times n minus 1 times n minus 2 all the way down to the number 1. Okay. Get a green line. Yeah, got a solid line this time. And then on the bottom, we still have that 6, and we'll get rid of it, but we go from n minus 1. Oh, sorry, this should have said plus 2. Plus
okay.
1, and there you go. Okay. N minus 1 times n minus 2 times all the way down to 1. So same as the other side, we have a similarity from n minus 1 down. All these values are the same. So they'll all eliminate each other. And when they eliminate each other, let's see what we get. We'll end up with, so we write this 2n times n minus 1 is equal to, on this side we have n plus 2 times n plus 1 times n, so still 3 terms, over 6. We can bring the 6 over and multiply, so that becomes 12. So we have 12n minus 1 is equal to n plus 2, it's lagging a little, n plus 1 times n. Okay, we have an n on both sides, so in other words, we can divide both sides by the value of n, and it will create a 1, so it disappears. Okay, so now we're left with 12 times n minus 1 is equal to n plus 2 times n plus 1. So now we start working with the idea of quadratics here. I think I'll speed this up. So I'm going to use some distributive property. We'll use the distributive property, and then we'll set it one side of the equation equal to 0. So we're going to distribute the 12 into both of these terms. So you end up with 12n minus 12 is equal to, and then when you do FOIL here, I'm going to quickly do it, it becomes n squared plus 3n plus 2. I'll move both these terms to this side, so they both become negative. So we're left with 0 is equal to n squared. 12n becomes negative 12, so positive 3n minus 12n, so those are going to be like terms. And then positive 2, and the other 12 is going to become plus 12. So we have to just collect some like terms. 0 is equal to n squared. This will become minus 9. Is that right? Yeah. And that will become 14. Okay. So now we got to do like some product and some factoring. Two numbers that multiply to 14.
7 and 2.
7 and 2, both negative.
Yeah.
So we need n minus 2 times n minus 7 is equal to 0. We set both of those equal to 0.
So it's 2 or 7.
Yeah, so 2 possible answers. N is equal to either positive 2 or n is equal to positive 7. And you could test them throughout it, but it looks like you're going to end up with the same thing and could be positive 2.
I swear we haven't done this in so long,
7.
like as in my class.
Yeah, it's a lot of work for a combination because you're really taking your grade 12 data skills Then and up to here is a really hard part, just eliminating. And then you're going back into like grade 11 stuff and doing a lot of factoring that you probably haven't done.
I'm
in a
probably